Properties of parallelograms. When we think about parallelograms, most people think of the quintessential picture that we have here. But I think what we need to start with is an actual definition. So squeeze this into your notes. Maybe right at the spot where it says notes. And write the definition in there. And what a parallelogram is a quadrilateral that has two pairs of parallel sides. Pair A and pair B. Right here. So two pairs of parallel sides. Opposite sides are parallel. Now because we have parallel lines, remember that we're going to have this opportunity to have alternate interior angles this way. We're also going to have alternate interior angles here. And of course, we also have alternate interior angles here. So lots of good stuff happening. Let's move on. These 5 properties are going to be the basis for our problem solving for the rest of this packet. I think what you want first is some blank paper, because I'm going to keep drawing some pictures and you don't have any space to draw these pictures. So get yourself a slice of blank paper. Our first property here is really the definition. And so when we think about a parallelogram, we think about a quadrilateral that has opposite sides parallel. So I would probably write this property right next to that picture. Second, opposite sides are congruent. So when I think about a parallelogram, I think about those are opposite sides and they're the same. These are opposite sides and they're also the same. So we got sides and sides. Now we turn to 3 and we start talking about angles. Opposite angles are congruent. So here's one angle and the opposite angle's over here. So these 2 angles are congruent and then these 2 angles are congruent. Now obviously all 4 are not congruent. Right here, this is an obtuse angle, and over here, this is an acute angle. So you can't have an obtuse equal to an acute. But these 2 are good, and these 2 are good. So opposite angles are congruent. Next we have consecutive angles. Consecutive, one right after another, are supplementary. So this pair of angles right here, they're consecutive, one right after another. Now this is nothing new under the sun. Again, these lines are parallel, this is a transversal, and these are consecutive interior angles. They've always been supplementary. But because the sides are all parallel all the way around, then we would have that these 2 angles are supplementary. And then of course, these 2 angles are supplementary. And then following again, these 2. So any 2 consecutive angles will be supplementary because they are same side interior angles of parallel lines. For our last piece, last conversation, number 5, the diagonals bisect each other. And what we're talking about are segments. Hence I have, this has to do with segment, segment, and segment, right? The maroon color all have to do with segments. Sides are made out of segments and diagonals are made out of segments. These are the diagonals. Okay, and what do? They bisect each other, which means that this piece got cut in half by the other one and this longer side got cut in half by the shorter diagonal. And hence we have congruent segments inside the parallelogram. Let's put this to use in solving. In this video, I'll do the even problems, and then you should probably press pause at that point and do the odds as well. When we are done, check in the whole set for credit with me. All right, let's get started. Now more than ever, I think that the advice to fill in the picture as much as possible is the best advice. right? Before I get going and answering these questions, I want to fill in the picture best I can. Using the properties from the front, as I fill this in, or attempt to fill this in, this side, MJ is 29. And from property number 2, about opposite sides being congruent, then this side is also 29. If this is 21, then opposite sides being congruent means that this side is 21. I know that opposite angles are congruent from rule number 3, or property number 3, so this is also 127 degrees. And then, with the idea that consecutive interior angles are supplementary, 180 minus 127 is going to be 53 degrees, so this is 53 degrees, which makes them supplementary as well, and that works, which makes these guys supplementary, or opposite angles are congruent, so if across the street is 53, so is that one. Now I can just go right down the line and start filling in my answers. Because I've taken the time to fill in the diagram, I can just look at the diagram now and answer. JK is 21, no units necessary, but perhaps this was feet, I might put like 21 feet. KL is 29, maybe I should just write the word units. The measure of angle J is 127 degrees. The measure of angle K is 53 degrees. And the measure of angle M is 53 degrees. So again, fill in the picture first. Answering this is a breeze. Press pause. Complete number 1. Once you're done with number 1, then move on. Press pause now. Okay, so in keeping with the tradition of trying to fill out the picture first, I noticed that down here they tell me the measure of angle FED is 134. So FED is this big guy right here. This whole angle is 134 degrees. Now, if this smaller portion on the left here, which would be angle FEC, this is 71 degrees. So 134 minus 71 would give me the other side of that angle. So that's going to be 63 degrees. So right here is 63 degrees. Now keep in mind I have all types of parallel lines here. So because this and this are parallel, then this is 71 on the other side. That makes them alternate interior angles. And then the other side is going to be the 63. Now if this big angle, again, was 134, then the big angle down here is going to be supplementary with this one. So 180 minus 134 is going to give us 46 degrees. So this whole angle is 46 degrees. And this whole angle is 46 degrees. And because this little piece is 40 or 21 rather on the upper section, angle CFG, then 46 minus 21 is going to be 25 degrees. So then this angle right there is 25 degrees. That 25 is alternate interior, so right here is the 25, and right here is the 21. Right? Alternate interior on the inside here. So let's just clean this up a little bit. So let's recap. Down at the bottom, they gave me that this whole angle down here, angle FED, was 134. So this whole thing's 134. Now because of that, they gave me that this little piece right here was 71. Well, 134 minus 71 gave me 63. Now, these are alternate interior, and these are alternate interior of parallel lines, with this being a transversal. Well, okay, I also have the same kind of situation going right here. They gave me that this was 21, so this is 21. Now I use the idea that this big angle here and this big angle here are supplementary. So if I got 134, 180 minus 134 gave me 46. And if this piece was 21, then 46 minus 21 gave me 25. And if that's 25, so is this. Now I get everything that I see. So I go up here, now I just have to learn how to, or maybe not even learn, but to remind myself how to name angles using 3 letters. So angle DEC starts at D, goes towards E, goes up to C. So we're talking about this angle right here. We'll call that question number 1. So that angle is going to be 63 degrees. Now we move on to CDE. CDE is the big guy over here. So that's going to be 46 degrees, as we have down below. ECD starts at E, goes up towards D, or C, down to D. So that's this angle right here. We said that that was 71 degrees. And our last one is DFE. DFE goes from D down to F, down to E. So that's this little guy right here. And that was 25 degrees. So it takes a long time to talk it through, but to do it on your own, you can fill it out pretty quick. And this is probably one of the more challenging versions. So now that you got 4, you do number 3. Press pause and take care of that one. Now for number 6, I drew up a nice big diagram. So let's take a look at what we've been given first, and let's see what we could fill in. First, we have that GHF is 34 degrees. So GHF would be right up here at vertex is H, and G and F are the sides. So that's 34 degrees. Now HJF is 124 degrees. So that's this big angle here. So I'm going to leave the marking for that on the outside, and I'll put the little degrees, or the angles for the degrees for the smaller angle, sorry about that, on the inside. So that's 124 degrees. And by the way, that means that across the street here, opposite angles are congruent, 124 degrees. And alternate interior angles leaves me that 34 degrees is right there as well. FKJ is 79 degrees, so starts at F, goes towards K, down to J. That's 79 degrees. Now we haven't talked about any angles in there, but these are just linear pairs and vertical angles. So this is 79. So now let's do some arithmetic. All of the red has been given to me, but I know that in the blue, that's 79 degrees. And off on the side here, I've done some arithmetic. 180 minus 79 is going to give me 101. So that's 101 because these guys are a linear pair, which makes the other side 101 as well. Now, if this is 124, then the big angle over here is going to be supplementary to that. So 180 minus 124 is going to give me that angle, which is 56 degrees. So the big angle here is 56, and the big angle here is 56. And now, because this little guy is 34, 56 minus 34 is going to give me 22. So this is 22, and this is 22. Now let's see what we can go answer because of that. GFJ is going to be the big angle over here. So we said that that was 56 degrees. And FGH is going to be the big angle there. We said that that was 124. HFJ, so the HFJ is going to be our traveling down right here. That little guy, we said that that was 34 degrees. Really, it was kind of almost given to us. HKJ is going to be right there. That's 101 degrees. JGH is right here. Let's see, we haven't gotten that one yet, so let's take a moment and figure out that. So what I have here is a triangle, and I have 22 and 101. So if I take the 22 and the 101 and add it up, I'm going to get 123. Take 180, because that's a triangle, and subtract 123, I'll end up with 57 degrees. Alternate interior over here is 57, and 124 minus 57, because this big angle is 124, is going to give me 67 degrees, so that's 67 and 67. Now, onward and upward, JGH again up here is going to be that 67 degree angle. FGJ FGJ is going to be right there. That's our 57-degree angle. And FHJ is going to be this little guy over here. That's 22. And GJF, G to J to F is going to be right here, and that's 67. So again, just using alternate interior angles, opposite angles, consecutive interior angles, triangles, lots of knowledge to go through and tear this one apart. And there's a lot to it, but I think you can do it. Now press pause and do number 5. Then come back to us and we'll keep moving on. Press pause now. Okay, well, you knew this was coming. We have the algebra. Now, as soon as you see algebra, you can really just start to gravitate towards, well, I know I'm going to have to use 11x plus 1, and I know that I'm going to use 19x minus 31 somehow. And what do these have to do with? They have to do with opposite sides. When I look at my properties of parallelograms, opposite sides are congruent. That's property number 2. So I know that these sides are congruent, and when their terms are congruent, I set them equal. And now, doing the algebra is pretty straightforward. I subtract 11x from both sides, and simultaneously, I might feel comfortable enough to add 31 to both sides, and just do everything all at one time. 11 minus 11 is nothing. 31 plus 1 is 32. 19 minus 11x is 8x, and 31 minus 31 is 0. Divide by 8 on both sides, and I'm going to get that x is equal to 4. It asked me to find yz. Yz is right here, so 19 times 4 minus 31 is going to be my answer. I get a value of 45, so x equals 4. I put 4 in for x, and I get 45 for a length. Just for ha-has, 11 times 4 is 44, plus 1 is also 45. So I'm feeling pretty good about that x value. Okay, you complete number 7 now. Press pause. Okay, again, I have 2x plus 7, and I have 5x minus 23. So now what do these have to do with? NS is the length of some sort of segment. So where is NS? It's right here. And then I also have length SQ. Where's that? That's right here. So what this is part of a diagonal. Now when I look at my properties of parallelograms, I notice that diagonals bisect each other. That's property number 5, which means that this piece and this piece are cut in half, or they're congruent because this whole length from N to Q got cut in half. It got bisected by the other diagonal. Long story short is these two pieces are congruent, so 2x plus 7 equals 5x minus 23. Now let's not forget, the final thing I have to do here is find the length from N all the way to Q. So I'm going to need both segments here, both of these lengths. I'm going to add them together for my final answer. But we're a little ahead of ourselves. I'm going to subtract 2x, add 23, add 23. If you feel comfortable doing that in one step, go ahead. If you want to do it in 2 steps, do it in 2. As I clean things up from left to right, that goes to 0, that goes to 30. My equal sign is still right there. That's 3x, and that goes to 0. Divide by 3, x equals 10. Okay, again, press pause if you need to. Now what am I going to do with that 10? I'm going to put that into 2 times 10 plus 7, and that's going to be 27. And then the other one is 5 times, 10 minus 23, so that's 50 minus 23, which happens to be 27. And both of these little halvesies here are 27 and 27. They wanted the length from N all the way to Q. So as I travel along that whole distance, that's 27 plus 27, which is 54 as my final answer. So x equals 10. 54 is the length of NQ. And now you have enough to do number 9. Good luck. On number 12, it looks like we have a pair of consecutive interior angles. And according to the properties in the beginning, that number 4 says that consecutive interior angles are supplementary. So 8x minus 12 plus 3x plus 5 is equal to 180. All right, let's combine like terms. That gives us 11x, and a negative 12 and a positive 5 is a negative 7 equals 180. I'm going to add 7 to both sides. I'm going to get 11x is equal to 187. Divide by 11, divide by 11, and I'm going to get an x of 17. Now, x is 17. What did they want? They want the measure of angle R. Angle R is over here, but angle R is congruent to who? Angle P, because these guys are opposite angles. So angle P will help me figure out what angle R is. So 3 times 17 plus 5 should be equal to the measure of that angle. Now, it is an acute angle, so we should get an acute measurement. So first we need 3 times 17, which is going to be 51, plus 5, which is 56 degrees. So that is the measure of angle R. Sorry about that. All right. If I wanted the measure of angle Q, I would just subtract 56 from 180 because they'd be supplementary, just like we set up here. And I think you have enough to complete number 11. 14, getting back to, a little bit more complicated stuff. And again, if I'm talking too fast, just go back and listen to me a second time on any particular problem. But we have angle ABC as 115. So where is that? From angle A to B to C. So that's this big angle. That big angle is 115 degrees. Now remember, this 4x plus 6 is alternate interior to this side. So that part is also 4x plus 6. And if that's the case, then the 6x plus 11, or minus 11, is also right here. So that's 6x minus 11. Now hold on a second. The big angle here, this big angle, is worth 115 degrees. Now because I know the big angle is 115, I can take the little piece here, the 4x plus 6, and the 6x minus 11, and I can add them together to say that 4x plus 6 plus 6x minus 11 must be 115 degrees. It's the same thing down here too. This is 115 degrees because this is opposite, right? Angle B and angle D are opposite angles, which are congruent in parallelograms. Opposite angles are congruent, so 6x minus 11 plus 4x plus 6 is still equal to 115. Now what? Let's take our 4x and 6x, combine like terms. Positive 6, negative 11, that's minus 5 equals 115. Add 5, 10x equals 120. Divide by 10, divide by 10, x equals 12. All right, folks, we got an x equals 12. Are we done? Oh no, they want us to find the measure of angle ABD. Well, to find the measure of angle ADB, I think I just misspoke. I took a minute to just erase. The measure of angle ADB, I'm just going to go find that in the picture. That's from A to D to B. That's this guy right here. That's 6x minus 11. So that's going to be 6 times 12 minus 11. So I grab my calculator and I say, well, 6 times 12 is 72 minus 11 is going to be 61 degrees. So the measure of angle ADB is equal to 61 degrees. And now you have enough to complete number 13 and turn in your notes when you're done. And that'll be that. All right. Hopefully this helps out. And again, the key is to fill out the drawing all the way and to use what you've learned about properties of parallelograms. It's highly recommended by me to, of course, help yourself to a flashcard or index card or whatever you want to call it. And write all those properties on it to save for problem solving. All right. That's it. Hopefully this was helpful.